Alright, so this is number 9b from the problem set. Two boxes, one with mass 60 kilograms and the other with mass 90 kilograms, are in contact with each other. A 600 Newton force is exerted on the 60 kilogram box towards the 90 kilogram block. If the boxes are pushed on a rough surface with a coefficient of kinetic friction of 0.2, calculate part 1, the acceleration of box A. So box A, if we look at our diagram, is the smaller of the two blocks. So we have our 60 kilogram box and we have our 90 kilogram box. That's A and that's B. The force is being applied to this block A towards block B. And so what that means, is as this block A is getting pushed into block B, they're going to be attached forever, right? This A and B are not going to become separated. And so what that means is that we can, instead of looking at block A individually, we can look at the entirety of the system, right? So if we're looking at the system, that's going to simplify the problem quite a bit. So if we're looking at the system instead of block A individually, what we find is that we have a combined block of 150 kilogram mass. This applied force is applied to the whole system. So we have a 600 Newton force. We have a force of gravity downwards, a normal force upwards, and we have our force of kinetic friction coming out backwards. Our goal is to find the acceleration of the system, and so we're going to have to end up using Newton's second law, right? We'll be solving this for the acceleration. The mass we know, it's just the combined mass of 150 kilograms. And so now our goal is to calculate the net force. And so we're going to calculate the net force using the sum of all the forces. And so this is going to be equal to the normal force plus the force of gravity plus the applied force plus the force of kinetic friction. And we know that the normal force and the force of gravity are equal and opposite, and so they'll cancel out. And so we're left with the normal force equaling the applied force plus the force of kinetic friction. Now, what I'll also say before going on is that east is positive. And so when we're putting our numbers into this equation, what we'll see is that this 600 newtons, the applied force, is positive, but then our force of kinetic friction is negative. So to put our numbers in here, what we're going to have is 600 minus 0.20 for our coefficient. Our mass is 150 kilograms, and gravity, the acceleration due to gravity, is 9.81. You put that into your calculator, and you get a net force of 305.7 newtons east. Right, and it's being pushed to the east, so we would hope that the acceleration is to the east. If this came out negative, it would mean that we made a mistake somewhere. Okay, and so now that we know our net force, we can rearrange this equation into the acceleration is going to be equal to the net force divided by the mass. And so that's going to be equal to 305.7 divided by 150 kilograms. We put that into our calculator, and we get 2.04 meters per second squared forward, east, sorry. And then for significant digits, we get 2 meters per second squared east.